So, basics of algorithms and what we mean about them. And just let me remind you about important 2 books that I believe they are going to help you in preparing for the final exam. Before I start describing what an algorithm, let me describe how an algorithm could change your life. There is a 17-year-old guy. He built an app many years ago, and he built it for a school, for his school. And all he wanted to do is to basically take the news of the day and summarize it into a small tweet. And then he will post that summarization into Twitter. It turns out after he released the app that Yahoo Finance, they're looking for a news digest application or an algorithm, something that could compromise the news of the day and shorten them so they can basically post it to all investors. And they bought this company from this guy. Yahoo bought it for 30 million when he was 17 years old. And this is what make an algorithm is a very important issue in computer science, because an algorithm is a description of how you could solve a specific problem. It's a set of instructions that leads us to a very optimized solution. So what we mean by an algorithm design, it is how we design a solution for a problem. So an algorithm always specifies a method to create a process where we could take the data as an input and generate an output out of the data. So there are 4 famous techniques for an algorithm, and we could study many of them, and each family of those algorithms could take us years to finish studying and enhancing. The first family is called the greedy algorithm. The second one is called divide and conquer. So let me now describe each family in details. So the greedy algorithm, it's always look about a local immediate solution. It is the same concept you use every time you navigate from your home to the college using a navigator app, and you look to the best route. You don't care about how much kilometers you are looking for to do, but you care about the time. So you always look about an immediate local solution. If I, for example, when I travel from my home to the college, I consider not the time, I consider the cost, and I have loads of time to spend on the journey, I could think about something else. So instead of taking the fastest route, I could take the bus, because the bus is the cheapest method to travel. If I don't care about expenses and I am a super millionaire and I have lots of money, I want to drive to work, I won't take a bus, I will look to the most local, immediate, optimized solution. So I will take a helicopter from my home to the college. And this is why we call it greedy, because we don't care how much computational resources we have. We don't care how much computational resources we are going to spend in order to reach a solution. We care about achieving the result, achieving the solution, regardless how much cost, time, distance, or any criteria we have. So a greedy algorithm always try to find this local optimum solution and maybe lead to a very global and generic solution. Not all the time every greedy algorithm would lead you to a global solution, but most of the time it does. There is so many famous greedy algorithms. One of them is the famous Knapsack Problem and the minimum spanning tree, the one that we use in layer 2 switching and in networking. When you go and you do networking science, you will find minimum spanning tree in every single switch in order to reduce or to generate a loop-free network. The third example of a greedy algorithm is called the traveling salesman problem, which we will discuss and study next semester in Fundamentals 2. It's a very interesting and important a graph theory problem, that we always solve it. And the idea behind the travel salesman problem, if there is a salesman and he wants to visit 50 cities at the same journey, how he could travel in all of them so he can visit every city exactly once and he return to his starting point. Now you could think about it, he could take a random approach, but how much the cost of random approach is, and which is optimal to travel from city A to city B, or city C, then B, then A, and so on. We will study all of that next semester. So if you look now, a greedy algorithm always try to travel, always to find an optimal solution in the local problem state. And what you have seen here, this is a binary search tree, and when we travel from 7 to 12, we find that this solution is not really optimum. So we go and we do backtracking from 7 to 3, then to 99. You look to 3 and 7, the numbers that you see here in the notes, look to them as, for example, cost, distance, time. You could look to those and interrupt them in any fashion. So to understand greedy algorithm, now let me just describe a simple problem in computer science. It is the knapsack problem. Now you have a bag and you want to maximize how much boxes you could carry in this bag so you can maximize the profit. Now the other type is called divide and conquer, and this is like a famous strategy. We always heard about it in the news and in political debate. Why? The reason behind the importance of divide and conquer is that you take a problem that it's so large to handle in one single shot, and then you divide it into small ones, and then you handle each one in separate so you can solve each problem alone. There is many famous examples of divide and conquer, and the famous one in computing, it's binary search. The idea of binary search, you take one single array and you divide it, and you want to search for an element in that array. So you take this array and you chop it, you divide it into two halves. Then you go and think about one single portion of that array, and you look for the element. If you can't find it, you divide it again until you make the array into small pieces so you could find, or you can't find, the key that you are looking for. Another one is called quicksort, and in recursion, when you do a recursive implementation of a quicksort, this is basically a divide and conquer strategy that you basically take the array and you keep passing to the sorting algorithm a small portion of the array at a time. So you basically take a problem, you split it into sub-problems, then you merge the solution at the end to make a global solution. The third strategy, it's called dynamic programming, and we call it dynamic programming because we solve an algorithm based on the fact that we use a bottom-up approach, not top-down approach, similar to divide and conquer. Here we always think about recursion. You take a small instance of that problem and you solve it, and then you go back to a larger set, and then you keep increasing the size of the problem through the iteration or through the program. Fibonacci is a very good example of dynamic programming. The last one is called backtracking. With backtracking, you travel from one point to another point, and you calculate the profits that you would make or the achievements of your goals. If you can't find any optimization from going further, you backtrack to the previous node and you consider traveling in different direction. There is so many examples of backtracking in computing, and one of the famous one is called 8 Queens puzzle, and there is as well the traveling salesman problem using backtracking. As a summary, it is a very important issue to understand the importance of algorithm design. Better algorithm needs or leads to a better program, and a better performance, and also more available and reliable software. And it's normally used to solve more complex problems. In computer science, we face problems all the time, and we need to find a better solution for them.